Okay, welcome everyone. So we've got our first AMA question with Andrew Stone, lead developer of Bitcoin Unlimited, and I'm Paul Church here asking questions, and we're going to kind of get into a conversation about them because there's so much to talk about. This is going to be one of many conversations, I'm sure. And we know the community has got like a ton of interest and want to know a lot more about Nexa and where it's going and what's happening right now and stuff. So yeah, I think we're going to cover as much as we can in here, but like I said, there's going to be a lot more that we have to talk about over the coming weeks and months and years. So yeah, it's really nice to chat with you, Andrew.
Hi.
Thanks for coming on.
Thanks. Okay, so you have a list of questions from the community, right?
That's it. Yeah, I've
Okay.
tallied up all the best questions, and we'll get started with first of all the most kind of asked and maybe the most important one to discuss first of all, which is so there seems to be a lot of buzz about blocks from CAS because we have quite a lot of our community come from the CAS blockchain, and so there's some kind of assumptions about that blockchains can only be fast and scale if they have rapid blocks. But this person's asked if we can go further into detail on the Nexa scaling technology and how block times will become irrelevant for Nexa potentially, and how Nexa can facilitate immediate transactions necessary for a kind of peer-to-peer cash or person-to-business transactions.
Sure. Okay. So first of all, I think listeners need to understand that having a rapid block time isn't like a total panacea because there's trade-offs, right? And basically, one of the key trade-offs is that the block header is effectively overhead, right? And in particular, your light clients, like your phone wallets and so forth, need to be tracking those block headers, right? So, for example, if you to reduce the argument to absurdity, if you decrease your block time to the size of a single transaction, right, rate, then the number of headers would be so large that they would exceed what a smartphone could handle, right? So we need to find some kind of compromise. So 10 minutes is a long time to wait, right? We chose a compromise of 2 minutes. And so this basically means that our header data will increase by, 5 times faster than Bitcoin's, which, by the way, on a full node is negligible on a computer, right? But, on a light client, it does need to track all these headers and, stick out with the network. And so reducing a block, block interval time below that starts to become a little risky, and additionally, the benefits start to be uncertain, right? For example, the lower you get as your block interval starts to approach the network propagation speed, you end up getting a lot of orphans, right? Orphan blocks, as in you end up with 2 competing peer blocks, right? Now, if that happens often, then you're basically undermining the validity of a single confirmation anyway, right? So if you end up having a very short block interval time, you end up having to wait for multiple confirmations anyway, right? Even beyond just needing to wait to achieve a similar difficulty level, you just need to wait because there's tons of competing blocks, right? So this becomes a problem. I don't think that the block time will ever really approach like instantaneous point of sale stuff, right? We have other technologies in play that is meant to cover that, and it will cover that in a sort of merchant risk type situation, right? Nobody needs to make like a $10,000, $100,000 purchase in 30 seconds, right? You need to make your groceries, your coffees, that kind of stuff very quickly. So we have 3 technologies sort of cooking. 2 of them are basically implemented or implementable at the higher layers right now, and those are double spend proofs, double spend alerts, I mean, and also double spend forfeits. And then the third one is what we call storm. So should I just go over what they are?
Yeah, definitely.
Yeah.
If I maybe I can just quickly summarize kind of the
Mm.
things you've said before, because it's maybe not clear to people that there's kind of two separate features or functions of a blockchain, which is speed of confirmation, or finality is like another way of putting it, and
Uh-huh.
then there's like capacity, and they're two very different things with like different kind of trade-offs to how they get achieved. So
Absolutely,
what
because you
you're
can
talking
have very large blocks. You can have a very high capacity, even though you have a slow block time, which we certainly support in Bitcoin Unlimited. And you can also have, very short block times with a low block size to create greater capacity.
right, and so what you're talking about now is actually finality, like how secure is that transaction from ever being undone or double spent or having like any issues with it, essentially.
That's right. Yeah. So, right. So double spend alerts is something, that we worked on with Bitcoin Cash. And the idea is, hey, if you see a double spend propagating through the network, then send an alert to the rest of the network saying this is a double spend, right? And you could always just send both transactions around, but that does give the miners the opportunity to choose the other one, right? And presumably the other one is the one that pays a higher fee, right? So what a double spend alert does is it provably says there is a double spend on the network, but I'm not going to tell you what that double spend is, okay? And so then, so you're not helping the double spender by giving out the alert, but at the same time the merchant sees that alert and says, well, let's wait for a few minutes, right? And in Nexa, with a 2-minute block time, that's not a long wait, right? So if once in a blue moon the coffee well, I mean, when you make a coffee, it takes you longer than 2 minutes to make a coffee anyway, right? But they have to say, well, your payment hasn't quite gone through yet. You're just going to have to step aside for a little bit. That's not, that happens very rarely. This is not the end of the world, right? Um, and um, and by the way, the only way that's happening is if, you are trying to double spend, right? Or like, you and your partner are sharing the same private key wallet, which would be a bad plan anyway, and you've accidentally done a double spend, right? So I mean, it's not like this isn't a probabilistic thing, right? If you get this alert, you provably know that someone is, you know, doing something nefarious with this transaction. Okay. And so then the second technology is, so that one exists right now today. The second technology is double spend forfeits, and the idea there is you can create a smart contract that says, hey, so your wallet would do this. Hey, I have some money that's been set aside, right? Say $50, right? And every time I make a transaction, um, it will say, if you can ever spot me double spending this transaction, then anyone who spots it can have that $50. So as you can see, for any purchase less than $50, it doesn't make a lot of sense for an entity to attempt to double spend. So and so then when you would present that payment to the merchant software would immediately see, oh look, there's a forfeit associated with this, and the forfeit is $50. The amount the person's buying is $20. We're just gonna go. We'll make the point of sale, like, app will just show green right away, right? It's like we don't like our software, we can write software that doesn't necessarily have to present all these details to the, to the merchant, right? We could just create a wallet API that, shows green or yellow or red or something like that. So all of these different technologies can be integrated into, one simple user interface. Okay. And then the third technology, which we have, proof of concept on, is Storm. And the idea there, so those two prior technologies work unless you have a miner, unless you're in cahoots with a miner, right? And before, you think, well, that's going to happen, do understand that, if you are, then your ability to cheat the system would be proportional to your hash power, right? And so asking like a major miner to basically commit fraud to buy coffees or something small seems very unlikely, right? But
especially
you
if it
need,
only works the percentage of the time that that miner has hash rate. So even if
that's
you're
right.
30% of the network, you've 70% of the time you're going to be standing there looking like a thief because it's been proven on the network.
Yeah, that's right. That's right. And that's a lot of coffees, right? So what you would really have to do to run these scams is like be doing something that has to do with cash equivalents, right? Like, withdrawing funds from an exchange or some kind of betting site or something like that, right? And so, these are not the very point of sale type operations that we're talking about, right? These are more, edge cases. But regardless, in order to basically somewhat solve, again, these are all risk mitigation solutions. The problem in that case, what we would do is use something called Storm. And Storm is like a pre-consensus technology. And I really hate that term because if you can get pre-consensus, then isn't that consensus, right? The entire term doesn't make sense. However, it does in this sense because what Storm gives you is a probabilistic number. What Storm does is it has miners send to the larger network a partial proofs of work. So the miners can say, hey, I did not find a block, but I almost found a block, right? And it has these transactions in it. So basically what a client can do is it can look at, okay, so what the network decides to do is it's issuing these partial proof of work blocks. And then you can look at these blocks and say, well, in the last minute, 95% of the network has found, partial proof of work for blocks, and my transaction is in 75% of those blocks. And, the other 20%, there's no double spend. So I know that, there's a 75% chance that my transaction will be confirmed in the next block. And by the way, there's a 95% chance that no transaction will be confirmed. I mean, no double spend will be confirmed, right? So you can see how you can look at these percentages, right? And so in order to defeat that, what you would basically have to do is take your mining hash power and have it not part of the Nexa blockchain. And then only when you're executing, an exploit, does that particular miner apply its hash to Nexa, right? So you're basically adding hash power into the network rather than switching it over to mining like a fraudulent transaction. So again, we're starting to get to situations that are very rare and esoteric with these technologies.
Right. These like the only way to implement them successfully is kind of like statistical attacks where you're having to do maybe like 1,000 or 10,000 attempts at this to actually get enough of a win that makes it worth it potentially.
Right, exactly. And can you imagine saying to a miner, okay, we're gonna spend 3 months implementing some custom software, and what it's going to do is load the Nexa blockchain GPU software and some other GPU software simultaneously on the GPUs so that we can dynamically switch back and forth. And so whenever I contact you to buy my coffee, right, or whatever, it's a small payment, because if it was a large payment you wouldn't be doing this, right? Like the merchant will be waiting a certain number of confirmations. So whenever I go to make this small payment, you're suddenly going to switch your mining, like you have to do it super efficiently, which is why this all has to be coded up, right? To switch between blockchains, like, pretty much instantaneously, you're going to switch over and start, mining, my fraudulent transaction, right? I mean, come on, right? Like that's a tremendous amount of development work for a very small, outcome. But this is where we get into the perennial argument of, people wanting these point of sale, like maybe researchers want the point of sale solutions to be perfect, right? Whereas people with practical experience understand that every point of sale, like
There's a risk associated
thing
with
is all, yeah, they like every merchant is doing risk assessment. So this would be just another risk assessment.
Right, like we were saying in the chat the other day, Visa just accepts the risk and just says, okay, we're including that in the fee, and that's what most payment software does. It just accepts as a risk and adds a fee for it. Which obviously,
Yeah,
like it would be good if you could implement a technology that reduces that risk by some non-negligible percentage, because then the cost could be reduced. So that would
yep,
obviously be an advantage. But it's not like a showstopper that there's
no,
some risk involved.
especially not for merchants. They're used to this. In I will give like a story that I heard from way before my time, but I've heard about a merchant solution which back before the internet, the credit card had to do dial-in, right? So even if the phone system was down, they would simulate the noise of the dial-in, right? So that the point of sale people would think that the credit card was being verified, and then they would just accept it if the network was down, right? So they would just be accepting these credit cards blind, right, to be issued later and simulating, the modem connection noises so that, the point of sale person, the salesperson and the customer thought that the transaction was actually being verified. So merchants are completely used to doing risk assessments.
Right.
Okay,
Yeah, that
so
that makes sense. So that's obviously the finality question of like how quickly a transaction can be finalized
mhm.
with a certain level of risk. And then the other side of things, which I think is actually kind of more relevant to Nexa and more relevant to cryptocurrency in general, is how are we going to achieve a capacity that allows it to really be a functional system for payments or transactions across the world, because that's really the issue that no other cryptocurrency has solved right now. There's a lot of centralized chains that kind of say they have very high transaction per second or capacity, but they've only really achieved that by being centralized. It'd be easy to do that on just a single database that everyone checks. But like, how is it possible we can achieve that on Nexa
Yeah, well,
while staying decentralized?
yes. So I think that um, people are going to always argue about this, right? Will the technology, because we cannot move faster than the ability to move this data through the internet, right? Um, at the same time, so the question is, will the fundamental baseline technology move forward sufficiently to allow this or not, right? Um, and I think the answer to that is yes, right? And we can do a lot to make this happen, but of course we can also rely on the relentless march of technology with satellite internet and the amazing number of uh, you know um, different wavelengths you can now put down a single fiber, right, to allow this incredible scaling, right? So, but so given that sort of stuff, it comes down to what can be done on a single computer, right? And so what we've done there is we have a strategy and we're beginning to implement it where we're using the mining job, right, to encourage development of custom hardware that will solve the bottlenecks in the blockchain. And the two key bottlenecks are UTXO lookup and transaction validation. And the key function of transaction validation is signature validation. So currently, the Nexa proof of work requires a elliptic curve uh, generator step, which is the first step towards, and one of the key aspects of doing signature validation. And so the, generation 2 of the, mining algorithm is going to require both UTXO lookup and some more additional signature style operations. So given that, we believe we'll have incentivized entities to both put these these algorithms into GPUs, which are actually um, significantly capable compared to what they used to be. So we could be like in a normal computer, you could simultaneously issue the validation of, say, 10,000 transactions, right? And those are going at, and I'm not saying you would do a billion of them per second, but those GPUs are operating at 1 gigahertz, so a billion instructions per second, right? So what exactly that ends up being in terms of transactions per second, we don't know. But then having encouraged this in the mining algorithm, we do expect that FPGAs and ASICs might come out that would do the same thing. And Bitcoin Unlimited hopes to sort of be involved in at least the production of some of that. And so we would envision a card that might fit into your M2 slot or maybe PCI slot that would, vastly increase the transaction performance on a normal computer, right?
Right.
So
Yeah.
if you don't know, like your M2 slot is something you could slap into a laptop, right? It's a tiny little slot that's normally meant to hold like a flash disk, right? So often a laptop will have 2 of them or even more, and so you can, it would look like a disk, but actually what it does is, UTXO set lookups incredibly quickly and stores them into its own, local flash.
All right, so yeah, this is actually answered a question that's we're going to bring up a bit later, but I should just rewind a bit because there's a kind of everything you said is not speculative. It is certain that we can speed up all of these operations using hardware that isn't just a CPU. Like the CPU is basically the slowest hardware or type of hardware that could be used to do these operations, but that's what is being used at the moment for,
right. So
as far as I'm aware, every cryptocurrency for validating transactions.
Yes. So this is anticipating this question that you have in the list, which is what is cache drive, right? So cache drive is a proposal for this technology that basically is a UTXO lookup, optimized hardware that does UTXO lookups and stores the UTXO, right, in Flash. And hey, if we're going that far too, it's not going to be too hard to throw, signature validation onto that same chip, right?
Right, I should explain just for people that are listening that don't necessarily know what UTXO is. So UTXO stands for unspent transaction output. Essentially, these are all of the pieces of information in the blockchain that really need to be tracked because they're all of the money, essentially. Everything else that's on the blockchain is just old information that you don't really need to keep around. Whereas UTXOs say, do you have money on this address? That's kept in the UTXO set.
Right. So it's like the current balances, basically, is kind of like a good way of putting it.
Yeah, these are the equivalent of not addresses, accounts on Ethereum, for example. It's the closest equivalent thing,
right?
Although not the same,
and,
obviously.
Right. And so basically, I think Gavin originally said, hey, the actual blockchain data is just of like, academic interest, right? So long as you can prove that this current UTXO, right, is the one that came from all of this history, right? So if you can get that done, then you don't really need all that history, right? And so that brings us into some other technologies, which perhaps for time we shouldn't really delve into, but UTXO commitments, right, are techniques to make a cryptographic commitment to a particular UTXO. And in the Nexa block header, there's already a spot for them, which we haven't filled in yet because we haven't implemented that, but that's coming down the line. And so that'll solve a couple of interesting problems. But one of the big ones is, hey, you won't have to sync from the blockchain all the way to the end. And you may have listeners may have experienced this with Ethereum. I'm not sure if it commits to its a blockchain UTXO current state database, but certainly in like Geth, there's a mode where you can say, hey, do a fast sync, it's called, of the blockchain by just downloading a UTXO set, right, and going forward. And I'm not sure how it decides that UTXO is the correct one or not. I haven't really investigated Ethereum so closely, but it
Yeah, I
has
mean,
this similar technology.
right. Yeah, I mean, obviously, you could just assume that the UTXO set you're getting is true right now, but it just might not be. There's no like security there to
Right,
prove that it kind
right.
of connects back.
Yeah, and so I'm not sure if they punted and just said, oh, okay, we're just going to download it from Ethereum.org, or are they actually committing, they actually creating a UTXO commitment, right, and putting that in a block, which is then backed by, well, okay, so since Ethereum is using proof of stake now, it can't even be blocked by hash power, right? But blocked somehow by the network consensus, right? Or not. So I don't know in Ethereum exactly how they're doing it, but I do know that they are using a similar technology, which is needed in Ethereum because it has a giant blockchain.
Right, and that's the important point about UTXO commitments is that is this the scaling aspect. If you have such a high throughput, then if you have to download the absolute entire blockchain from Genesis block to today, then that becomes obviously an increasingly large problem the longer time goes on.
Yeah.
Whereas if you only need the UTXO set, that's only going to grow, maybe not linearly, because obviously the more useful the network is, the more the more usage it's going to get over time, and so people are going to have probably more addresses and stuff with money on them. But it's obviously not going to grow anywhere near the same speed as the entire blockchain from day one. So
right, and you can
yeah.
say, hey, eventually it will be proportional to the size of our population. And so unless you're really, engaging in science fiction, you can say, hey, that is limited by the resources on Earth, right?
Right, exactly. So as soon as
So
the technology enables that level of usage by the people, then it won't, that's it. That's the size of the UTXO set.
right. So on this planet, there is a maximum reasonable UTXO size that we can imagine. I haven't bothered to calculate what that is, but it is something that will basically eventually sort of even out.
Yeah, I mean, I did some numbers recently, and it doesn't. It's not crazy. So I think a UTXO is what, maybe 100 bytes, something like that, for like a normal
for a simple
transaction. Yeah.
Right.
So what's that? If you do 1 billion people times 10 UTXOs, that's like just that terabyte, something like that. So we're not talking about super far in the future sizes of storage or anything like this. You can buy a 1 terabyte SSD for like $50 right now. So
yeah, and also the script template system forces you to put your scripts inside not the UTXO, but when you do the spend, right? So it actually I think 100 bytes is a little bit of a high value, because the actual script template commitment is 32 bytes, and then you might have an args commitment. So you're going to have about between 32 and 64 bytes more likely per UTXO. Right.
That makes sense. Yeah, I hadn't thought about that. Yeah, the actual outputs are very
because
small.
You're no longer putting scripts in UTXOs in Nexa. You're putting a commitment to the script, right? Okay. Anyway,
so yeah, I mean that pretty much covers it. So it's like this reducing storage. There is something we haven't talked about is how bandwidth is reduced, which is like through compression technologies like Xthinner. I don't know if you want to cover that quickly, just so we cover everything on how Nexa is going to scale.
Okay, so I guess obviously, so this technology has been deployed in Bitcoin Unlimited for a long time. It was used in even Bitcoin and in Bitcoin Cash. But there's two technologies called Xthin and Graphene, and what they basically do is they use summarizing technologies to only transmit the transactions once, and then when the block is sent, it says, oh, you've probably seen all of these transactions already. So I'm just going to give you a summary of what the transactions are actually in the block. Okay. And I don't think we want to go into tremendous detail, but they use clever techniques of like set differences and things like that and Bloom filters to say, hey, you know, give me like a fingerprint of the transactions you have, and I will send you all the transactions that don't match that fingerprint. And there's a probability that you're 1 in a million or something that you're missing a transaction. If so, you just ask me for that one, right? So it's that kind of stuff. And in the end, the blocks end up being a very small portion of the network load. It's actually the IMS, the announcements, hey, I have a transaction. Those turn out to be the highest network load at this point.
Right, and it's because when the block is announced, because it's just communicating this missing data as opposed to every single transaction that's in a block, this stops it stops it from causing lots of orphans, because the time to actually send it to all the other miners remains always low, kind of no matter how many blocks are included in the transaction. Is that like a good kind of summary?
Yes, exactly. And so that's also really helps block propagation times, right? And so that's reducing orphans. So, all these technologies kind of work together, and maybe nothing is, a panacea solution, but they're all just making things a little bit better, and they all should add up to something awesome. At least that's what I think.
Yeah, I should also point out to people, because we get a lot of new people coming in the community, and often they're thinking that this is kind of like a new project, but a lot of people don't understand that a lot of this technology has been now years in development already. It's just that some of it may have been implemented, some of it may have not been implemented in any other blockchain yet, but the work is not just kind of been popped out in the last year or so. It's been an incredible amount of work over years from Bitcoin.
Right. So so for consensus changes, for non-consensus changes, we deployed them in Bitcoin or Bitcoin Cash for many years, right? And even for things like Wally Wallet, no one's really seen it, but I've been using Wally Wallet with Bitcoin Cash, right, for years now, and I just never wanted to maintain it, right? From a customer support perspective, right? And so now that it's moved to Nexa, you're actually using like wallet infrastructure that has been around for several years, right? And the same is true with the full node, right? We did all of this optimization work on Bitcoin Cash, and we were the first group to show blocks with a billion transactions in them. And I mean a billion signature transactions, right? Like, one input and one output type stuff, or two inputs and one output, not, blocks that have a significant amount of data in them. And of course, we did that on a test net, right? Because no Bitcoin at the time didn't handle 1 gigabyte blocks, but all that technology, is in Nexa, right?
And that, I should say, that
in
was
terms of
before
consensus changes,
Yeah.
I had this next chain, testnet chain that I was running for about a year before we even received the sort of vote, the okay vote to begin Nexa, right? So next chain technology became Nexa. So we were working on these consensus changes beforehand. For example, the actual proposal of script templates actually comes from the group tokenization proposal that I made in Bitcoin Cash from 2017, just to give you a sense of how long some of these ideas have been, at least within Bitcoin Unlimited, and how we've had quite a bit of trouble getting the child of group tokenization is going to be deployed in Bitcoin Cash. So I don't want people to think that in May, right? So I don't want people to think, oh, these guys are shouting and no one's listening. There were political reasons and so forth that prevented these good technologies from entering the Bitcoin Cash space.
Right. I mean, this is kind of an always always unfortunate part of cryptocurrency technology development. I was explaining to some of the community the other day, like the history of what's it called now? It's on the Bitcoin Core compact blocks. That
All right.
the Bitcoin BTC has compact blocks, a scaling technology, which has no purpose whatsoever because Bitcoin has no plans to actually scale now. But it only has that because Bitcoin Unlimited is produced X thin, which instead of just implementing on Bitcoin BTC, they had to rewrite into something else that was essentially worse. So they
Yes.
have a scaling technology which they don't use or have any need for, simply for political reasons.
Right. So yes, exactly. So what happened there was that, the big blockers and the small blockers are having a debate. And so the small blockers cannot use a single line of big blocker code, right? And so I think Mike Hearn came out with this, with a technology that first used Bloom filters. And then the small blockers came out with, an idea called compact blocks, right? Which was like, we don't even know if it really existed, okay? But retroactively, we were shown a, wiki that a small blocker had administrative privileges to, right? Which purported that compact blocks was invented, before our implementation of XThin, which is a child of Mike Hearn's work, right? And yeah, and so then having come out with the implementation of that, the Bitcoin core community kind of freaked out and said that they needed something. So they rushed out and did this compact blocks and then, showed this wiki that proved to everyone, that, they had this idea beforehand, even though they easily could have jimmied the dates because they have it's a private wiki run by a private individual in Bitcoin core. But regardless, this kind of shenanigans was just so painful to deal with in the Bitcoin community. All we wanted to do is have this technology. And you are right that, so as an engineer, I have to be very specific. Compact blocks is slightly better if you look at total bandwidth, okay? But our technology, X-thin blocks, it has a more even bandwidth going in both directions, okay? So it uses slightly more bytes, but you see it uses a more, there's more bytes sent and received. So to some degree, we're handling twice the capacity. Am I making sense?
Yeah,
Like,
so you mean as in
compact blocks is
bandwidth?
only sending, it only basically sends data, okay? Whereas in XThin, the entity that's asking for the block sends a non-trivial amount of data to the producer of the block, okay? And so if you sum the data that's sent from the requester to the producer plus the data that's sent from the producer back to the requester, that happens to be larger than that of compact blocks, a little bit, right? But the fact is that we've effectively doubled the pipe because we're basically, communicating bidirectionally, right? Whereas in compact blocks, it's all just sent in one direction.
Yeah, that makes sense. Mm-hmm.
Yeah. So you can certainly debate which one's better, but it's like, who cares? Like, they're both getting 98, 90, 8.5%, right? And then graphene comes along anyway and blows both of them out of the water. So like, why are we even still debating it, right?
Well,
And
there is no debate because they don't need compression
right.
technology.
And so, of course, Core has never implemented graphene because they don't need block compression, right? It's one megabyte a block. So, yeah. It's funny that Core has some smart technologies, but it's
just kind of
utterly
wasted.
Yeah, it's utterly useless because the block is full with the basic technology, just sending. So why deploy anything else on that blockchain if you're not going to, allow any additional capacity? And I think people understand that, which is why additional innovations are all like, hey, we can do smart contracts on top of Lightning. We can do, it's all on top of, a technology that can actually scale.
Right. I mean, I guess that is a good summary of the whole kind of scaling situation. that everyone, like every cryptocurrency, seems to be trying to do scaling by extremely complex solutions that kind of may work, may not work. Is kind of all unknown at the moment. For sure, it's making the user experience bad unless you obviously then have to build quite complex like applications for them to all interact well together. Like if you're having shards or different layers, all of these things just make it
Yes,
more complex. Whereas on Nexa, it will just be like a cryptocurrency like Bitcoin, except for you can have as many people as you like using it. And
absolutely.
with kind of this takes us on to the next question.
Well,
And
let me just say one more thing about that, which
sure,
is
sure,
Nexa. y- I haven't kept up with all of the changes in Bitcoin Core, okay? But Nexa will do Lightning better than the original Bitcoin will, right? And I think actually then SegWit actually will as well. But I don't know about the next thing, right? So you see, because I'm not going to sit here and say that Lightning is dumb, okay? But what is absolutely dumb is not allowing, um, not scaling the layer one stuff as greatly as possible, as efficiently as possible, because we know that that works, right? And if you throw all your eggs in this one basket of a untried complex technology, which is Lightning, then you're just making like you could see when this happened. The community was split right down the middle between the academics and the practical people, right? Just boom, instant split, right? And so why would you want to do that when these two technologies are actually compatible, right? So
yeah, yeah,
I don't want to hate on Lightning, right? All I want to do is say, hey, we're going to scale layer one, in an intense and awesome way. And yeah, if we run into actual physical limitations, like, the ASICs we produce, top of the line ASICs cannot handle transactions that fast. Yeah, then we can look at something like Lightning, and eventually, probably at that point, Core will have fixed all the problems for us, right? So we'll just grab their code and off we go, right? And so now you're going to have Lightning on top of a layer one that still is insanely fast, right? And how awesome will that be compared to having Lightning on something that barely works?
yeah. And kind of and going back to your original point, which is that there is a large amount of scaling happening, even if there's no improvement in blockchain technology whatsoever. So I mean, I have a very easy example here. Just installed in the last week here is just a 1 gigabit broadband connection just for people's homes as just
Yeah,
standard. Like I don't even live in a city, so it's not like I'm in some special location where this is a strangely fast broadband connection. This is now becoming standard. And okay, if you go back to the original block like scaling wars, which was what's that, maybe 8 years ago now. What was a normal connection back then? Maybe 30
yeah,
megabits or 40 megabits. So,
yeah.
just that time alone has increased the bandwidth by, what's that, 20 over 20 times faster,
Yep.
just
And
from nothing.
it is hard to write code that will pull a gigabit per second offline rate and process it, right? Like like so this is why we're talking about technologies that can do that, right? Like I in my previous life as a network protocol engineer, like I did that, right? And we had to do some pretty crazy tricks, right, to make that sort of thing happen. And so, yeah, you are getting to a point where actually the network capacity is exceeding that which a laptop can process anyway, right? So I'm not super worried about the network capacity, especially because I am not, I don't feel like um, the Bitcoin core people that every single individual in, the deep hinterlands of some location needs to have a full node, right? Like I think we talked previously, in terms of scaling about how having light clients, right, and not making the job of a light client really hard by having blocks produced too rapidly, right? And so, light clients are really important, and anyone who has lower bandwidth can run a light client. End of story, right? It's just in terms of the security of the system, it's just important that anyone who reasonably needs to run a full node and do some mining can, sort of assemble a group to do so, right? So, if we end up having to use like, 1 gigabit per second type connections, which are available to anyone who has an optical, line, and in some like, and keep in mind, this is like in some amazing future where Nexa has succeeded beyond our wildest dreams, right? Then that's what we'll do, right? That'll be okay. And by
Right,
then,
sure. And obviously by
by
that,
then you'll be
sorry,
able to
go
buy
ahead.
10G, like, if you're in the city, you'll be getting 10 gigabits per second, right? It's just
Yeah, on your
people
phone.
in,
Yeah.
yeah, on your phone, right? Right. Yeah. So, uh, but it's okay that if you live on a farm, out in, Illinois or Nebraska, that, well, I mean, I even hate to say that because satellite, SpaceX might come through and they might be sending you gigabit streams down by then, right? I mean, the whole world might be covered with incredibly high bandwidth communications. But if it happens not to be, that's not the end of the world. If like, the full node that you're running has to be in, the city that's an hour away from your farm, right?
Right, exactly. So I think that's a very good like summary then, or kind of deep discussion about how Nexa is going to achieve scaling, which is obviously
Mm-hmm.
through bandwidth, or the requirement for bandwidth to be compressed as small as possible, for storage requirements to be reduced as small as possible, um, and the actual ability to process and validate transactions to happen as quickly as possible using basically hardware acceleration. So they're like the
Mm-hmm.
three main points of how Next is going to do that. And so this brings us on nicely to the next question, which is what will be the advantage of Nexa smart contracts over Ethereum, Solana, and other such projects? Because this is where I think things get very interesting. Like it's good that we
Yeah.
have the capacity for everyone, but how do we actually make the network really, really useful to people?
Yeah, that's a good question. And I've always been a huge fan of smart contracts and tokenization, even though like back in, 5, 6 years ago, people were purists saying, the blockchain should only be for the native coin and smart contracts shouldn't exist, blah, blah, blah. So I've thought about this deeply. The thing to understand so for all those other projects, we're going to call them EVM projects, right? Ethereum virtual machine projects. And the key thing to understand about the EVM is that it's like you're running a normal computer effectively that's, highly redundant, right? And so, it's Turing complete, which means that it can play all kinds of games and tricks, right, on you. And the key, and so it's also extremely powerful, right? But one of the key issues that we're seeing with that is what's called the blind signing problem. I wrote a blog post about it a while ago. But basically the idea is, hey, you're given a Ethereum contract and MetaMask just says, hey, do you want me to sign this contract? Yes or no, right? And you just have to sort of trust the website that produced the contract and say yes, right? And then it goes, and because it executes code that can modify the blockchain um, to its entire, to its level of permissions, which since you've signed that, that contract means anything that you can do, it can do, right? So, what has happened in Ethereum is that people have been tricked into going to various websites, and then, they're promised, if they show that they have this NFT, they'll be given this other NFT, right? Or something like that. So they click, sign the contract. But what um, that arbitrary program does is it actually steals your NFT. It doesn't give you a new one, right? It can steal everything out of your wallet if it wanted to, right? So now what Nexa is the Nexa smart contracts only basically decide permission to spend. Okay, so a transaction says in a unmodifiable fashion, these are the, this is the money that's going to be spent, right? These are the tokens that are going to disappear from your wallet, and this is where they're going, right? And there's no possible way that execution of the contract can affect that. So, for example, in Wally Wallet, if you scan a QR code, it will say, this is a custom transaction that you're being asked to sign, right? It removes one NFT from your wallet and it gives you, 200 necks, right? Do you want to do this? Yes or no, right? And there's no way the execution of the contract can avoid that. So in that sense, the smart contracting capabilities of Nexa are sort of much more user friendly, right? Since the actual effect of the contract is specified right up front, right? You can't trick the user. However, that does mean that it's slightly less powerful, but deliberately so, right? That's the intention. Than an Ethereum contract, which can basically modify, modify blockchain state, sort of, you know, just arbitrarily depending on the execution of the code, right? So, um, so I think it's an advantage, but what I'm trying to basically say is the philosophy of Nexa, I've said it before, is to make like a financial blockchain, right? So what Ethereum actually is it's a massively redundant computer which has finance layered on top. So this is a very different thing, right? And so we have primitives, for example, to execute tokens, right? And by primitives, I mean that, since the contract itself doesn't have to enforce token semantics, like that tokens aren't created or destroyed, for example, that's what I mean by token semantics. That can happen very efficiently, both in terms of blockchain space and also in terms of the size of the contract and the time it takes to execute, right? And also in terms of the user safety, right? As I was saying, you know when you're about to lose a token because it says so, right? Right before you sign the contract. So these, I think,
Yeah,
are the advantages.
and I should add that, to what you just said there, there's no ERC20 or something like that standard on Nexa because tokens are standard on Nexa. They
That's
just
right.
come as standard built into the chain. And we've discussed this before in the past. The reason for this is because tokens are already a proven use case that is extremely useful and have brought enormous value to the cryptocurrencies that have implemented them. So there's no point in requiring some complex contract to create them when you can just have them natively on the chain.
That's right. Yes. And so, yeah, in that term, native tokenization, I think I'm the one who invented that years ago. So, I just want listeners to understand that we've been thinking about this for a long time, right?
Right. You can go back and see your posts about it
Yeah.
from years ago. And it's been
Yes.
one
And
of the main kind of things that Bitcoin Unlimited tried to get onto Bitcoin Cash and ultimately couldn't, although a simpler, less capable version is now being implemented later this year. But the goal has been to add it for a long time, like you say.
Yes, of course. Yes. And so, yeah, I think my original post on Bitcoin Talk is back to like 2012 or 2013, right? So, when Ethereum is talking about layering tokens on top, I was talking about, no, they should be native, right? Yeah, and
It's
then there
another
was a big gap
little.
as we
Sorry, go
did the
ahead.
blockchain wars. And so then once Bitcoin Cash forked, I just quickly wrote up my ideas in, my original posts on group tokenization. And so that's, how that happened.
Yeah, I should add an extra detail as well. Although tokens are native to Nexa, just directly in transactions, they still get access to the full smart contracting capability within Nexa. So it's not like, oh, you can just create some tokens, melt them, send them, and let's say change the authority. You get full access to it, the tokens get full access to the full smart contracting capabilities.
Exactly. The only thing that you don't, yeah, it's just that in that contract, you don't have to like write specific code to enforce the quantity of the tokens, right? And that actually protects both holders and also, the token creator, right? So there's a lot in Ethereum where actually the holder of the token is not protected. So as a simple example, like for an Ethereum token, every contract implements ERC, the ERC itself, right? So really what you need to do as a token holder is download the source code to that contract and make sure that it's implemented token scarcity properly, right? Like if you get an NFT and it says there's only one of 5,000 in here, right? Well, you really ought to download, that contract and make sure that only 5,000 can be produced, right? How many people do you think do that? But
None.
in the Nexa
Yeah,
blockchain,
close enough.
right? So the Nexa blockchain, what you can do is you can look at what by you I mean your wallet, right? Can basically look to see whether there are any mint authorities available for that group through the blockchain. It would be part of the UTXO set. Is there a mint authority in this token? If the answer is no, then you know that no more of these tokens can ever be printed. End of story, right? So again, instead of having to, so this is again a difference. Like we can algorithmically go through and write code for you to do that, right? But whereas if you're working with, the Ethereum virtual machine, which is a, fully Turing complete machine, there's no, like you provably cannot write code to analyze arbitrary other code to determine whether it does something. It's called the halting problem. It's like a well-known, and so they might make stabs at it, but you you'll always be able to fool that kind of system.
Yeah, that's why there's gas, isn't it?
Yeah, but what I mean is like, well, so what gas really does is it says, hey, you can't, your transaction is too big, right? And so you have to burn some coins. I'm talking about like whether you can write code that will analyze a contract to determine whether it will say ever mint more NFTs than the 5,000 that are promised, right?
Sure. Okay. I see
And
what
so
you're saying.
yeah, and so you can never write code, but you are right that like because the halting problem is unsolvable, what you also can't do is prove that the Ethereum transaction will ever, like processing will ever halt. And so what Ethereum does is it says, well, if you run out of gas, right, then we just halt the transaction on your behalf. And by the way, we charge you the maximum amount, right? And so there also have been people who have gotten lost a lot of money because they accidentally wrote something or the price of gas increased, right? And so their large contract didn't quite run to completion, and then boom, right?
Again, that's like a major issue for developers because then they have to write the smart contract code in a way that if it runs out of gas, it doesn't like destroy the contract completely. Like it would be fine if you could just, they have to write it in a way where you can always add more fees, essentially gas to it if necessary. But if you don't write it that way, yeah, you could have like a, I don't know, like a Uniswap contract or something that just died because it just ran out of money or something.
Yeah, because the cost of gas does change, right? In ETH. So yeah, it's more typically what happens is the cost of gas changes and a person doesn't supply enough ETH to cover the consumed gas in the contract, right? Or perhaps the state of the Ethereum blockchain causes the contract to, run longer than expected, and so it consumes more gas, right? End result is that you lose all that gas, right? So none of that can happen in the Nexa blockchain because transactions input very specific state, right? And then they run. And so that's another issue. Another advantage too is, by the way, once a transaction like when inside the full node, a transaction is run once, right? And if it's good, then that transaction never has to be executed again. Yes, you have to check the input data, right? The UTXOs that are being spent to make sure they still exist, but you never have to re-execute the contract. Whereas in like something like the Ethereum virtual machine, um, it is not, you know, pulling in and destroying unique state, right? It's modifying existing state in the EVM. So it's theoretically you can modify the EVM state and then you can apply the contract, or maybe you ran the contract before you modified the EVM state, right? And so you have to keep rerunning the contract to see whether it remains valid as the Ethereum state changes, right? And so this can cause unanticipated problems, as we've been pointing out, where you think that the transaction is going to run with a certain amount of gas, but in fact it takes a lot more, right? Or something like that.
Right, and it's the key as far as I'm aware, it's the key reason why it's so unscalable, right? Because
Yes.
it just constantly is referencing other things that can kind of change the how the smart contract operates.
Yeah, so you can pull in any piece of state in an Ethereum transaction. You can just write arbitrary code that, would hide what piece of state it's going to pull in, and then it suddenly does it, right? And so, whereas in, Nexa, you have to specify exactly what state you're pulling in advance, and you're not allowed to pull in a random piece of state, right? You have to pull in exactly what you specified at the beginning of the contract, right? And destroy that and create new state, right? So that's a giant advantage, is that we only need to execute these transactions, like full nodes only need to execute the transactions once. And also in terms of the end user too, like the end user can execute the transaction and, like simulate it effectively, right? And if it passes, then, the end user knows that the transaction is going to work unless one of those pieces of input state has been already consumed, right? Already used by some other transaction. And that's the whole double spend that we're talking about. It's where a piece of input state is used by another entity. But you can never get into a situation where that piece of input state changed. So the execution of your contract will change. Either that state exists and it's exactly the same as it was when you used it, right? Or it's gone and your transaction is no longer valid. So you got to create a new transaction. So there's not going to be
Yeah,
any surprises.
right, exactly. And this is also why you can make everything parallel, process in parallel. Is that
Yes.
the transactions are kind of like themselves little programs, or really sets of little programs. Each input is a little program, where they, other, like you say, other than the inputs, they're just processed on their own. So you can put 10 transactions being processed, validated, for example, exactly at the same time.
Yeah, there's a key piece of technology that we created in BCH time, and we actually proposed it in like the scaling Bitcoin 2015 or 17 or something, and that is we use basically a simplified, optimized version of the Bloom filter, and we check every transaction's input as they come in, just the data that it's referring to in the UTXO with every other input transaction. And we do that probabilistically using a Bloom filter, which means that we might we might sort of accidentally think there are some conflicts, but we'll never like miss two transactions that actually don't conflict. And so for all of the transactions that pass, we know without a doubt that they're modifying different state in the blockchain. And so what we can do is execute those transactions simultaneously, validate them simultaneously. And then, oh, by the way, if you had an accidental collision and this probabilistic algorithm says, oh, these two transactions might conflict, but they actually don't, doesn't matter, because that one of those two transactions is just delayed till the next round, right? And then it goes through. And we're running these sort of parallel rounds of transaction execution like many times per second. So from the perspective of the user, like if your transaction is delayed to a subsequent round, it still is happening almost instantly, right? But that allows us to issue Well, in Bitcoin, right, Bitcoin Unlimited right now, and then, our full node software, we're issuing, I don't know, like, as many cores as you have, we're running transaction validations in parallel, right? Um, and so that technology is already done, right? And so the interesting part is basically expanding that technology out now into like GPUs, or maybe even FPGAs and ASICs.
That's interesting. I didn't actually know that that technology existed. So when you say conflicting transactions, do you mean, for example, transactions that spend from an input that may not necessarily have actually been processed yet, or from an
No,
output? Sorry.
yeah. So what we do is we're looking for two transactions that spend the same inputs, right? So this
Oh,
is
so
just
just a double spend.
exactly right.
Okay.
And so the question is, how can you very efficiently scan for double spends, right? And you don't want to do it by looking that data up in the UTXO set, because that's half of the job, right? So what we basically do is create a Bloom filter of the hash of all of those inputs, and we compare that Bloom filter against all the other incoming transactions. And what Bloom filters do is, they will sometimes, they will never tell you that you know you that you that two transactions don't conflict when they actually do. But every once in a while, it will tell you, hey, I think these two transactions do conflict, right? We have a Bloom filter match, even though they don't, right? So it can give you like a false positive, right? But that's okay, because we just defer one of those two transactions to a subsequent round, right?
Right. So yeah, that makes sense. So you just have a low false positive rate. Is that right?
Mm-hmm.
And therefore, it doesn't really matter if a transaction or two gets through and takes an
That's
extra,
right.
I don't know, millisecond.
Yeah, exactly. And we've certainly, sized this Bloom filter to, have, spurious conflicts very rarely. One in 100,000, is the chance, or one in 10,000. I forget the exact number, but it happens very rarely that you'll have you know, a conflict uh, that doesn't really, it's not really a double spend.
Interesting. Yeah, I'm gonna have to look into this technology. I didn't know it existed.
Yeah, so
Um,
that allowed us to crush out the transaction validation and produce the gigablock blocks, right? That was sort of a
mhm.
key feature to it.
Fascinating. Okay, right.
Mhm.
It's probably a good time to move on to another question. So
Yep.
this question we probably get asked more than any other question, which is why the 5,000 blocks wait on the block rewards. We have a lot of miners in our community, and we have this question asked a lot.
Yeah. So right. So the intention is to encourage miners to not rapidly switch between blockchains, because obviously rapid switches are detrimental to actually all blockchains involved, right? Because what we really want for each blockchain is a constant hash rate, right? Um, and so if you're going to mine Nexa, the result of your mining is you're not going to be able to spend it for like a week. So, does it make a lot of sense if Nexa is, if suddenly Nexa is, 1% more profitable to mine, in this particular minute compared to some other cryptocurrency, does it make sense to switch over? No, right? You as a miner, need to be willing to hold on to these coins for a week. You have to ask yourself, well, what's the price of Nexa going to be a week from now? So we are and so first of all, changing it to 5,000 was, a very easy change, literally like 10 minutes, right? To try and create this outcome, right? I'm not going to sit here and say, that it's the best solution or anything. It was a pretty good solution that could be implemented very, very quickly.
All right,
So
it's
that's
interesting because I've never really thought about it like that. It's basically stabilizing the hash rate by introducing instant or uncertainty in the knowledge of what the price is going to be when you spend those coins, essentially. when you're able
Yeah.
to spend those coins. So it
Yeah.
just, yeah, it creates that uncertainty, just create a stable equilibrium, which is a weird concept to think about.
Yeah. I
Uh,
mean, and if you really wanted to do this right, you might like somehow create some scheme that pays out the miners over the next 6 months to a year with, ever decreasing, payouts, right? So maybe they only get half their coins 5,000 blocks from now, and then a quarter at 100,000, right? And that, you know what I'm saying? It just trickles down, right? That would be really the most effective thing. So then, a miner could say, really would have to think that Nexa is, a good coin for the long haul, right? But before they moved money over, or more likely, like because you're paying out in a sort of exponentially decreasing fashion, they would say, well, Nexa is now 10% more profitable, so I will move over, because although I don't know what's going to happen in 6 months, right? Like I'm only making, that 6 months to a year, I'm getting 10% of my, reward. So something like that obviously would have been cooler, but that's a lot of work for perhaps a relatively small amount of gain, compared to just saying, hey guys, you got to wait for a week,
yeah, I think also the week
you can't just
forces
mine and
the
sell.
miner. Right. Yeah, which a lot are still doing, but then that is why we get this question asked. So
Right.
like often is that they come and
Oh,
be like, oh, but I haven't got paid.
I'm
Like,
sure they
yeah,
hate
yeah,
it.
yeah.
I'm sure they hate it, right? But that's the idea, like the miners, of course, they don't really love, the Nexa algorithm, but boy, they would have loved to have, it be the Bitcoin algorithm, or, one of these other well-known algorithms that they have code for, right? But, we want the miners to work for us, right? Not for themselves to some degree.
That's exactly why I've explained to people is that miners are providing a service for Nexa, which they're getting
That's right.
paid for, and not the other way around. Like Nexa doesn't
Right.
exist to pay miners.
Yeah, but miners hate to hear that. So
Yeah, but it's true. Like
no, it is.
they don't have to mine, but because of what the price is, there's always going to be another miner right there willing to take their place. That's just
Yeah, and if
the
not, the
incentive system.
difficulty will go down, and then a miner will be willing, right? So,
Right.
yep.
Exactly. Which, to be fair, the difficulty won't go down because they will be, there will just be a miner there willing to come and mine it because it'll be profitable for them to do so. At least, as long as they
Yep.
think that in 7 days
Yep.
the price will be, what they think it will be anyway. So,
Right.
so
But it
yeah, I
certainly will
think
discourage miners from jumping in for a day and jumping out, right? Like, oh, if you decided to mine next day, you believe the profitability a week out. So why aren't you going to mine for at least a week? Like, what changed in your assessment, right?
right, exactly. Okay, so I think we answered that question.
Yeah.
I hope people understand this. I know miners don't like it, but I think it's actually good for the network.
Yeah.
So next question is, with regards to the roadmap, could you elaborate on the funds and other resources that are going to be needed to achieve it? I assume they mean like from Bitcoin Unlimited, as opposed to just generally people in the community.
Yeah. Well, so Bitcoin Unlimited was funded um, well, we were funded with a small amount of money, which we did not spend. And so now it's grown into, a large, that initial funding has grown into a large sort of nest egg. And, we do plan to continue to develop Nexa using, the Bitcoin Unlimited funds, because that is what the voters have said, right? And so we do not, we were a fair launch coin, right? And I think that's really important to recall. We have people jumping on all the time asking that, right? That question. So don't expect that we're gonna create a $100 million, startup fund for people who do stuff on Nexa, right? Because we are fair launch. We're not, you know, um, we got the small amount of coins that we were able to mine. We did not run out and throw. beyond being fair launch, we took that to heart, and we did not throw 1,000 VPSs onto mining Nexa either, right? So, you know, we have some of our own coins that just makes sense, but we do not have the sort of the quantity of coins that would be needed to like fund our own development out of these coins or create giant, you know, multi-million-dollar initiatives, right? But having said that, we do have the funds to continue, a similar level of development that we have had, and even expand it, you know, in sort of reasonable and careful manner. So I guess, let me see, what does the question exactly say? Yeah, so I think that's basically answers the question.
Yeah, so I should also add that kind of to what you're saying, although Bitcoin Unlimited has committed itself to obviously building on Nexa, maintaining it, upgrading it, doing whatever it can to make it successful, it is not in a privileged position really
No,
above anyone else, because like you say, everyone, the organization and the individuals in Bitcoin Unlimited have had the same access to coins on Nexa, the same as everyone else has had access to them. So I think it's going to be important that even though B will fund some things, I think it's going to be important that the community both funds and produces things that they will find valuable for the network.
absolutely.
Because the more valuable the network is made, the more funds people therefore should have to at least put a percentage towards things that they think would be valuable. It doesn't have to be necessarily into things that BU thinks needs to be done. They may feel that, I don't know, some a new wallet of a specific type needs to be built. Go ahead and put money into that. Go ahead and develop that.
Yeah, yeah, and I mean, I think perhaps this is an important thing to say and to basically put out a warning, right? Like this is another way that we're not like a pump and dump, right? We don't have like the funds to pump, create all these initiatives that sound really good on paper, and buy entire arenas or whatever in the world these other cryptocurrencies are doing, right? We don't have the funds to do that. What we have the funds to do is some good solid engineering, right? And a little bit of marketing to let y'all know, what's going on, right? But everything else we don't have the funds for, and we don't want to, because the intention is not to pump, and also we don't have the funds to dump either, right? We don't, like, there are these coins that are holding 50% of their coins, right? Well, that's a giant dump hanging over your head, right? We don't have those coins, right? The only coins we have are ones that we either mined or acquired on the market, right? Just
Right,
like
this is
everyone else.
exactly, yeah, exactly. And this is one of the main benefits of proof of work without a kind of pre-mine or anything like that, is that because everyone has the same access, it's very difficult for anyone to gain an enormous share. I mean, you could see that
That's
especially
true.
where we went from CPU mining to GPU mining. The more competition there was, obviously those coins got split between increasingly like large numbers of people. And so unless you maybe like I don't know how you pronounce his name, Andrew, the guy, or Andre, the guy that produced
Hmm.
Wild Rig. He's probably one of the few people that's in a position that can even accumulate like a percentage of that size, and that's only because his
Yeah,
miner is so good.
yeah,
Um,
probably.
but even still, like that is going to be nothing in percentage compared to these coins that have pre-mines, or pay the team 20% or something of all the supply,
Yeah, I mean,
whatever it may be.
to give like a good example, like I was thinking of running like over Christmas some kind of fun little project, right? And I was saying, hey, what I should do is I should give like block one coins, right? you know, out. So it wouldn't be like for the money, but it'd be like for the cachet, right? But I'm the lead developer. I didn't actually mine block one, turns out. I was close, right? But like somebody else, some unknown person got block one, right? Not me. So,
Right.
what as far as I know, Bitcoin Unlimited developers did not even get the first block.
That's pretty funny. Yeah.
Yeah.
I mean, that is a pure fair launch. Like even BU didn't get the first first
I
block.
don't think they did. I haven't actually asked everybody, but
Yeah. I didn't. I think I only started mining after like first week or something like that. But yeah, so we announced it. Anyone could have found out. Like, obviously, it's not possible to let every single person in the whole world know that Nexa existed on
No,
day
and I
one.
mean, we
But we
tried
did what we
hard
could.
to, and we tried, and like if you go to Reddit cryptocurrency and you make such an announcement, they delete your post, right? Like there
Right.
are so many altcoins out there that we had a very hard time trying to say that we were special. So we did our best to announce it months in advance. We had website and we made announcements in various places. We had a Reddit, subgroup called Nexa, which was, indicating that we were going to launch at a certain date and so forth. But and I did put into the Genesis block, a headline to prove that we hadn't pre-mined the Genesis block, right? And that's the best we could do in this, this cryptocurrency world with so much, buzz and excitement and, scam coins and just an incredible boil going on, right? So we did the best we could for the pre-launch.
Right, exactly. I agree. Okay, so I mean, we've already covered the question on Cache Drive, which is a way to hardware accelerate access, data access to the UTXO set. So we can go to the question after that, which is any ETA on the wallet app for Nexa. So do you want me to speak about that? You can speak about it if you like. I don't mind.
I think we can both speak. I'll just say first of all that, Wally Wallet on Android, like I have a non-trivial amount of Nexa on it, right? It has been around for years. It is still in, open testing, experimental. That's mostly because, it is a financial app and, so buyer beware, right? Like, it's code, it needs a lot of runtime. As I said, I've been using the core for many years now, right? But there always can be exploits. So it is good to consider these things experimental. For some sort of phone wallet, I think it's always good to only have what you can afford to lose, just like you lost cash in your wallet, right? Because what if you lose your phone, right? So Wally Wallet does implement features like allowing you to, put a passcode in to unlock accounts and things, but its UX is really dense and not what I think people necessarily want to see today. Besides that, it's highly functional, right? So there are trade-offs there. We're currently, fooling around with making a iOS, at least getting the beginnings of an iOS implementation. That's going to be at least a few months out, though. And then, yeah, you can continue on with some efforts to, reskin the wallet and talk about that.
Yeah, so another project that I've got a team working on is to, yeah, like you said, is to basically put a new user interface on Wally Wallet that's just a bit more user friendly. Maybe it looks a bit more similar to like other wallet apps that are out there. Obviously, the underlying code is just the same, which is obviously the part that takes the most work. And I do actually use Wally Wallet. That's actually one of my main wallets. It's not where I store most of my coins, obviously, but it's the one that I use if I need to like send some to someone or anything like that, because it's just easier. But yeah, it definitely takes like a bit more game. You have to know how it works, and then it's
For
fun.
sure. I mean, yeah, and like as I'm a developer and I also did the UX, so that should give you a sense of how user-friendly the UX is, right? It's a developer UX. You can do an amazing amount of stuff with an incredibly small number of clicks, right? But you got to know what to do first, right? And I understand that, and I plan to make Wally a little bit more user-friendly, but at the same time, it's always going to be the wallet where I deploy the experimental new features first, right? So, and to do that, there's always going to be awkward user interface type stuff because we're trying out these features. And so then, these other wallets can come in and they can, make it beautiful and user friendly and make it all work, real nice for the beginner.
Right. I think that's it. The key to UI is like you have to have someone be able to come in and then just instantly understand what's going on, which is a surprisingly hard problem because you always think that it's just obvious, but then, and it may be for like 50% of people. but then there'll be like
Yeah.
25% of people that can't understand that, and you make it simpler. But then there's still another 25% that can't understand that, and you're always trying to get it down to like the lower common denominator of people that really struggle with any software. So
Right. And
yeah, so
I like there's this saying in software development that you basically have to write code 3 times before you get it right. And I think that's true uh, with user interfaces as well. So I don't see like these two wallets as being competitive because, we have to, like if I come out with a new feature, I have to put it into Wally. We have to look at the interface of Wally and be like, oh man, that's just awkward, right? And then, we're like, well, people like this feature, so let's move it in, to the more user-friendly wallets, and then let's look at what's all the mistakes that Wally did in the UX, and let's try and make it actually, user-friendly, right? So
yeah,
I
and
think
I
that'll work
quite
out really well.
Yeah, definitely. And I quite like the idea of just being able to very quickly access features like before it all gets like cleaned up and made like super easy for everyone.
Yeah.
I'm very excited about getting tokens on Wally Wallet just so I can start using them.
Yeah,
And
and I've
obviously they'll
got
be there
like
before anywhere else.
Yeah, exactly. And it's so frustrating. I keep getting distracted with other things, but I've got the assets page. I've got a list of assets. I just got to populate that list with actual assets, right? And I even have a user, an RPC under. So like Wally actually can work with assets, okay? It just can't show them. So like it's kind of ironic. Like if you know that you have the asset hidden inside the Wally wallet, right? Then you can go to like a website, like the NFT website that I made, and you can actually use those assets, right? But you can't see the assets in the wallet. So we're close, right? But I think someone did ask a question on Reddit, when, right? The problem with ever asking an engineer when is that we have to make sure the code is solid and tested, and we have a lot of other things that we need to do. So I can't give you a when, right? Because then if I do, then that date becomes more important than like code quality. And so then people lose money, right? So I'm never going to give like a hard date for something that has to do with a financial, you know, um, piece of software
Hmm.
because I
But
got
I
to
mean,
feel good
basic,
about it.
right. But the wallets will come out over the next months, essentially,
Oh yeah,
that
yeah,
people can use.
yeah, definitely. Like I'm
Hmm.
saying, like all I got to do in Wally is show the assets, right? So I'm pretty close.
Hmm. Cool. So I think that answers that question. This is
Mhm.
an interesting one because I think there's a lot of different opinions on this question. So I'm interested to see how you're going to answer it. But the question is, will it be possible when energy consumption on Nexa escalates like Bitcoin to switch to an alternative that requires fewer resources that harm the climate?
Right.
It's talking about proof of work, obviously.
Yeah. So yeah. So um, the first thing to say about this is I do also believe that I was the first person to observe that like the interesting connection between highly uh, highly variable load and like cryptocurrencies, right? And so I wrote a post way back in 2012 about how if you could overbuild a solar farm and basically have a bunch of miners, consuming that extra energy, and so that would basically allow you to turn off peaker plants, which are your most polluting stuff, right? And so I think that there is this, and I also posted at that time about this idea that you could almost magically sort of transmit energy and without actually transmitting it. And the idea is, hey, turn off the mining where you need the energy and turn it on where you have a surplus. So if you did that, it's as if the energy magically got transmitted across the world without any efficiency loss, right? Okay. Um, so I think I was the first one to sort of wrestle with these concepts. And so I am not convinced that that consuming, like obviously consuming hydrocarbon energy to um, mine cryptocurrencies is not a great plan, right, for the environment. But consuming free energy, and by free, I'm trying to say energy that is naturally produced due to an infrastructure that's already been enabled. So solar, wind, and hydro, right? This is actually a dramatic benefit, right? I mean, there are cases where energy prices have actually gone negative in the United States. Literally, they pay you to consume energy, right? Because they don't want to. Basically, demand has to meet supply. So if you have oversupply, like they
It's
have to
bad for the
shut
network,
off,
right?
yeah, they have to
Hmm.
shut off power supplies. And it takes time and energy to shut things off, especially like nuclear. I guess nuclear load doesn't like to change its base load. So rather than having to shut down the nuclear plant, or bring it to a lower level, and now you've got to turn off. Now then, demand increases a little bit, so now you have to turn on peaker plants that are burning hydrocarbon. It would be better if like you could keep your nuclear going at a certain level, right, and have something that consumes that um, that extra supply. Um, so I feel like the jury is still out as to whether um, this sort of consumption of energy is like a net negative to the world or not, right? It's very different than, say, having like a plant that produces aluminum, because you have to shut down the entire plant if you don't have a surplus of energy. And so those are people who don't get to work, right? Whereas shutting down a couple of miners is, you know, not a big deal, right? Okay. Um, so having said that, I will say though that, if the situation arises that, well, so I'll talk about my personal opinion of proof of stake, right? So I think that Ethereum is like a strong cryptocurrency, right? And I don't mind its transition to proof of stake. Um, if you really think about it, proof of work is really valuable when a coin is first launching to ensure a fair launch and so forth, right? And also to stop a variety of attacks. But when coins are well distributed throughout the ecosystem, then some of the dangers of proof of stake start to go away. So while I would move to a proof of stake system extremely reluctantly, if like there was some kind of external force driving Nexa in that direction, like let's just say significant economies in the world make proof of work illegal or something, I would, yeah, I mean, I would move to proof of stake, right? I'm not going to let this coin die on proof of work, right? But in general, I would want to see that these ideas around, you know, cryptocurrency mining being the perfect, uh, variable load for alternative energy, for green energy, I would like to see those ideas not pan out before
Hmm.
we start considering proof of stake. And by that time,
Sure.
presumably, the distribution of Nexa will be good enough so that a lot of the risks to proof of stake, just like Ethereum, a lot of the risks of moving to proof of stake will no longer exist.
Plus, also you have to consider on Ethereum, most of it was distributed in the ICO at the beginning, not actually from proof of work mining.
I know, and that is definitely a problem with Ethereum, right? Which we're avoiding. But for proof of work versus proof of stake coins themselves, that is the problem with proof of stake, right? If we did proof of stake, then I would own 100% of Nexa, right, from block one. And then what I chose to hand out to other people would give them more stake, right? But ultimately, there has to be a block one, and one person's going to own it. Or maybe we could have handed it out to, myself and other BU members, right? But still, it begins in a highly centralized fashion, right? And then,
Hmm.
of course, there's the chain rehistory attack, right? Where you buy, people
Buy
spend the
old
coins.
coins, yeah. Hmm.
Yeah, you buy old coins that no longer exist in that space, and then you create an alternative story, right? Reality blockchain that uses that stake from the past to create an alternative chain, right? And then you say, there's no way to prove which one is the main chain, which one is not, right? Okay. Well, guess what? If you've been running proof of work, so your coins are like highly distributed across a million people, then it's very hard to buy, like just physically, it's hard to contact all those people asking to buy old coins, right? As opposed to, if you started with proof of stake, there might be 10 or 100 individuals in the beginning that basically have, 80% of the stake. So you could just contact those people and you could easily buy up 51% of early stake.
Yeah, and I think it would be fairly easy to defend against as well, because the only way you'd be able to even have a hope of contacting a large number of people is you'd have to put out a public message saying, sell me your old addresses that
Right.
used to have coins on them. And then it would be very easy to then just identify where they're being, like, who they're being given to. And you could say, okay, well, all of those addresses are now, like, blacklisted officially in the network or something like that. So
At least you would know that an attack is incoming. Yeah. And you might be able to
right.
hard code in like some defense of such an attack. You might be able to do that in subsequent releases. Yes.
Mhm.
Whereas, if you're able to reach back into a proof of stake system back to when the stakeholders were very few, it makes it much easier to run this kind of attack. So,
Mhm.
you know, but there's a, perhaps more important question, which is, should Nexa as a group with limited resources go off and start exploring this area, right? And I
Right.
think
No, I don't
the
think so.
answer is absolutely not, right? Like
Mhm.
what we're exploring is, actually using proof of work to massively scale, right? And someday, after we do that and ASIC people and miners have made like very large profits, so miners, don't panic and think we're going to be switching to proof of stake anytime soon and resist, making ASICs, right? This is, this is not going to happen soon. So once they've made tons of profits and we have these ASICs all over the place, only then, you know, would we even start to consider such a thing? And other cryptocurrencies have already done all the research and so forth, right? This is just not where I think we should be spending our time, right?
Oh yeah, definitely not. I mean, again, like even going back to what I just said, then Ethereum, it would take a very long time for me to trust that proof of stake is a good system after Ethereum having it, and it's literally only just transitioned to it. I mean, it could,
Yes,
fall on its face in like 3 years' time
right,
when,
right. We got to let
it's,
yeah, we have to let attackers have a chance to actually think about and analyze this, the system. Um, yeah, and we also, you know, I think in a blockchain you can spend your time like optimizing the internals, or you can focus on externals. And I think we've had too many blockchains that are looking at internals, um, and so that's why we as a industry still get this criticism like of well, where are the use cases, right? Now it's funny, every single time a new use case comes, like a finance use case, people always say, well, where are the real use cases, right? So to some degree this isn't that fair of an argument, right? But on the other hand, we still don't have people using cryptocurrency on a daily basis, right? But it is so much easier to make a payment than it is to type in your credit card. So what is going on there? And it's even easier than PayPal, right? Where you have to type in some strange password that you can't remember, and you debate the security of the computer that you're putting it on, and it's a website. Anyway, just going on and on. So, I think that there's a lot of things that Nexa should focus on at a higher priority than trying to figure out proof of work versus proof of stake. Scalability, user applications, you know, interesting smart contracts that, using Nexa's sort of more financial contract system, right, might be like a lot easier to use and a lot safer than like Ethereum smart contracts.
Yeah, I completely agree with you. I mean, this actually perfectly does take us on to our next question,
Hmm.
which is, what has been the grounding
Oh,
effect
yes.
that keeps you all on like the path you want to go on, and in 10 years from now, how do you picture Nexa's use cases? So, yeah, we can have a chat about that, because I think this is a very important question. Like you just brought up, like it's fine having all these incredible blockchain technologies, but if no one's actually using them, what's the point? Ultimately.
Right. And like way back in the day, um, somebody said like, there will be a computer in everyone's house, right? And other people said like, no way, right? So like, you know, uh, Bitcoin might be digital gold to their massive stupidity, and Ethereum might end up being a for like the blockchain for very complicated financial contracts, right? But like the wallet that's going to be on everybody's phone is still like I really I hate to say this because I don't want to give any other cryptocurrencies ideas, but I'm going to say it, right? The wallet on everyone's phone, the cryptocurrency on everyone's phone is still like wide open, right? And so that's what I'm going for Nexa. So I don't imagine that there's going to be these incredibly complex, difficult smart contracts. I just want, I mean, there could be, but like we have so many simple things to do to just enable simple contracts so that people can do stuff that they might do every single day. So that's what I want to focus on. I've always felt like that's the point of a peer-to-peer cryptocurrency. I've always thought that it like having dollars and gold is a problem. Yeah, you can save gold and you can spend your dollars, right? But why not just have one thing that does both of those, right? Well, there's reasons in the fiat system versus like gold, right? But if those reasons suddenly disappear, as in with cryptocurrency, why reinvent that separation, right? So we can make a cryptocurrency that is both sound money, right? Fair launch sound money, and it can be the cryptocurrency that is in your wallet, used on your phone every day. So that's where I'm interested in pursuing.
Yeah, I think this is the hardest question in cryptocurrency. It really is. Like,
it is.
Why? Given like assuming all the technology works perfectly, why should anyone care? Like, why should the average person in the street care? Because we can get the whole of like the current cryptocurrency ecosystem interested because Next will be worth more in the future, and therefore all the gains and things like that. Like, that seems to be an easy thing to do, which is why most cryptocurrencies seem to focus on that. Like, oh, you're going to get rich quick.
I barely even care about
mean,
that. I consider that poaching
right.
our own, friends, right? Like,
Right.
Sure, some of it is gonna happen, but really, I want to reach out and get new people. And yes, that's hard. So Bitcoin Unlimited and Nexa is like positioned for the long haul, right? We got to try something, and it may not work, or it may get 0.0001% of the global population, and then we got to try something else. And we can't throw away the first thing. We can't let it run out of business just because it was top heavy and it's paying $500,000 in C-level salaries, right? We just got to keep that thing going, and we got to come out with something else, and we got to try something else and something else, right? And eventually we're going to come up with an app or something that some use case that is very useful, and that will start the ball rolling, right? Or we won't, and we'll show that cryptocurrency is not appropriate for that. And this would have been an incredibly interesting experiment, and we would have tried hard. But I personally think I get so frustrated with the current financial system. I just am pounding my head. So
oh yes,
I don't
it's
think
terrible.
that's going to happen.
Yeah, it's terrible. I mean, like, just PayPal is an incredibly popular application and service. Yeah, it's just terrible. Like, you have to put in a ton of information. They can just take your money if they want to. They can just close your account if they want to, which happens all the time.
Yep.
Like, this is a terrible user experience. Yeah, this is one of the biggest payment companies in the world, and it was kind of like the first big payment company on the internet for making payments. So, and it's not really changed very much. It's basically the same format that it was, from 20 years ago. So
yeah, when I teach my class, I have fun with this sort of stuff too, because I have experiences and so forth. And you just like, if you wonder, I say just take out your credit card and look at the back, right? So they have the number on the front, and then because they needed additional security, they needed like the double dog secret number, so they printed it on the back, right? Like this, like, and so now you have yet another number that you have to type in. which gives no additional security whatsoever. And by the way, you have to type in your name and like your date of birth or whatever, and when the credit card expires. I mean, come on, like why?
Yeah, I'll have it. There's a
Why?
signature on the back, which the signature doesn't. No one even uses a signature in the UK
No one.
anymore. So it has a
No one.
signature slot, but it doesn't. It's not a required thing anymore.
Yeah.
So,
Yeah.
and how
Yeah.
difficult is it to copy a signature so that someone that's never seen your signature before, like,
It,
can't
it's
recognize it? That it's
yeah,
different.
it's incredibly easy, right? And you know, like international payments is a complete disaster, right? Your funds go through multiple banks. I've had, you know, multiple international payments. Just people still owe me money internationally because, you know, the wire transfer was rejected in some intermediate bank, and they never explained why, but something was wrong. My address was misspelled, my name was misspelled, something, right? Didn't quite match, right, in the receiving bank. And it goes through 3 or 4 banks to get there. And like, come on, you know? So there's so much space. So we can win this, but you know, it's going to be a long haul because, you know, there's education. So, you know,
Yeah,
so
I
that's
mean,
what we
I
have to
personally think
position ourselves for.
there's already like a lot of use cases that you can see being built on Ethereum, for example, that are blocked by how expensive they are to run.
Mm-hmm.
So I personally think like DAOs, decentralized autonomous organizations, are a massive use case, which is kind of just underutilized because the networks they're on are just too expensive, or the actual software itself is just too complicated to use. You know, a DAO, you could essentially use a DAO as like a one-click company. Click a button, oh, choose some settings or something, and you've got a company that doesn't require all of the crazy overhead that it actually takes to run like a company brought into being by the law, essentially.
Right. Right. Yeah.
Yeah, like especially where so many people now interact as organizations internationally, like Bitcoin Unlimited, for example. You know, we're all spread across different countries around the world. Kind of doesn't, although BU is set up as a legal company, I can imagine organizations like BU or other ones that get brought up. It's just easier to just exist on the internet and not exist as a legal entity brought into being by, I don't know, the UK government or, you know, the American government or whoever it may be.
Right. Right. And think about how about invoices, right? So, you know, even your auto bill payer in your bank, right? First of all, you know, it's completely unknown and obscure how in the world someone signs up for that to be like, you know, a merchant that gets paid, right? And secondly, like, you know, it can't be done automatically. Um, and like, so you basically have 2 choices. Either like the company can suck whatever money it wants out of your account, right? Because you just give it permission. Hey, just take whatever money you want out of my account. Go for it. Have fun, right? Or you
You have that.
basically,
It's called a direct debit in the
no, that's what
UK.
I'm
It's like
talking about.
yeah,
Yeah,
it's
no, it's a
crazy.
thing, right? It's a thing.
Yeah.
And people just basically tell like gyms that they can suck whatever money they want. I mean, they presumably it's a certain amount, but that's all just trust that the company can actually take whatever they want out of your account on a monthly basis. And by the way, in the US, you know, it got so bad because in order to actually quit that, like it's very easy to sign up, but you know, the gyms never wanted you to quit. So you had to like, you know, write a handwritten letter to the central company and finding the address to do that. And they had one person processing these, whatever. You know what I'm saying? It was really hard to quit, very easy to join. So it's just a giant scam, right? So, you know, maybe what we should do is have a wallet where the invoices just sort of appear, right? You don't have to go there. It gives you a notification, it appears, and then you just click like pay, right? And you get to decide, right? Like, so, you know, I have this technology I'm experimenting with, which is, you know, I call it trickle pay, but the idea is, hey, you can set limits, right? So, you know, you can, this company can deduct this amount from my Nexa wallet, you know, within every month, right? But if it's more than that, I want to know about it. You have to, you know, give me a yes, no question, right? That kind of stuff. You know, like we shouldn't ever, like there should be no paper invoices in this world, right? But
Yeah, I agree
there still
completely.
are.
There
Yeah.
still are, and the funny thing is like if you're doing accounting as well, you have to provide the invoice. I mean, there's software now that kind of like scans the invoice and tries to find the relevant
Yeah.
information. But I mean, and this is not really a cryptocurrency problem. This is like the financial industry problem. There's no just standard format for just a piece of data, like I don't know, a JSON file or something that just has all of that data just in it. I can't actually believe, like from learning accounting for business and stuff, that isn't just a standard thing in
I
business,
know.
that a payment comes with a chunk of information of all that data you need for tax purposes, or just even for like your own accounting to see
Yeah,
what's happening.
it's crazy that that doesn't exist, right? And even more crazy though is why even have that, right? Why have a piece of data that has to be, copied everywhere, right? And in a well-known format and everything, right? Because you can't necessarily trust that data. So let's say you get this JSON data, and maybe it's your bank statement, right? Or you get why do I have to still get a snail mailed paper copy of my bank statement? Because what if I wake up the next day and the bank says my account number is, my value is 0 in my account, right? What do I do? Well, presumably I take the pieces of paper I was mailed and I go to the bank and I say, it's now 0, but last month it was, a real number. Where did all my money go? But this is nuts, right? Because they're going to be like, you just printed that out on your laser printer, right? We didn't actually send you that. You're just making this stuff up, right? So for all these reasons, like actually all this financial data should be stored in a distributed database that anyone can access that's publicly available. That is a blockchain, right? So, there's so much need for this, but people haven't realized it because they're just so used to dealing with, this endless amount of pain with sort of the day-to-day finance stuff, or more accurately, probably they just don't deal with it. They hope it doesn't, matter, and they probably get cheated and bilked like 5 times a year, right? But they don't even notice because it's only $5 or $10 per hit, right? Per touch, you know. That's
Yeah, well, you
probably.
just
I mean,
have to pay
who
an
actually balance?
accountant a large sum of money. You just
But
have to
like,
pay someone else to handle it.
yeah. So like, do you actually like balance your checkbook anymore, or do you just like assume that the bank knows how to properly add? Like, do you take all your credit card charges and do you actually add them up, right, yourself? Or do you just assume that the bank added them properly, unless like you charge $500 and it comes up as $10,000? You know what I'm saying? But if you were cheated by like 5 or 10 bucks, would you notice because you're actually doing all the adding or not?
No, of course, no one's actually going to add up their account and see if it
But
all
they used
balances,
to.
for
They
sure.
used to, right? So I think that, I think that because back when the bank was having human beings do the adding, actually mistakes were made, right? But I think it's like having a blockchain that is a centralized location that verifies the integrity of that stuff makes a lot more sense than what we're
Oh,
doing today.
definitely. Yeah,
Yeah.
of course. And you can do like there's so many different things that could be possible for it. Like if you did, let's say you need to go to, I don't know, you want to get a mortgage or something for your bank. Right now, you literally just have to, like you say, print out bank statements. If it's not with your own bank, you have to print out bank statements, take them to the other bank, and then go like, oh no, here's all my incomes and outgoings and stuff like that,
Right.
as opposed to just be able to just click a button and then have it 100% proven on the blockchain.
Right.
Like surely that's
Right.
better for the banks, to know that this is verifiably true transaction data.
Yeah,
Um,
it's like this, this challenge transaction technology that I was talking about, right? Where,
mhm.
the you can formulate a transaction that the wallet knows is absolutely illegal and invalid and will never be on the blockchain, right? Because it's, the transaction is specifically formulated to be illegal, right? Okay, so what's the purpose of that? Well, it allows you to prove that you could spend this output, right? If um, the transaction was valid, right? And so what that lets you do, and is not just so it allows you to prove that you have control over a whole bunch of money on Nexa, right? Even if that money is held in a complex contract, right? So, this sort of thing exists where you can be like, well, I'm going to just, sign a message using my public key, public private key pair. Well, that only works with, pay to public key hash outputs. It doesn't work for multi-sig or just any of these other contracts. So yeah, you could totally show up to the bank and be like, sure, the bank gives you a bunch of challenge transactions, and you just in one fell swoop automatically prove beyond a shadow of a doubt that you have control over these outputs. And by the way, they can look back and see your transaction history as well, because you've also signed. They wouldn't have to be able to do that, but you've presumably signed challenge transactions for previously spent data, therefore divulging your transaction history as well to the bank, if that's what they need.
Right. I mean, obviously, we're just like coming up with ideas here on the fly of like how it could be useful, but there's obviously like endless different ways that would make things better than they are right now, in a way that's actually fairly easy to do with cryptocurrency and basically impossible to do on like traditional financial system.
Absolutely. So I don't think the problem is a lack of opportunity here. I think the problem is that we need to sort of focus on those opportunities and try them and keep the companies going, or the features happening, even if they're not instantly making massive amounts of money. Because as you can see, for the things that we're talking about, it's a relatively major change in the way that societies do business, right? So it's going to take a while.
Yeah, that is definitely something that I've learned over time, is that we are progressing into a kind of cryptocurrency world, but it's just been very slow for a number of reasons, but we're kind of just getting there.
Yep.
But I personally think the main detractor from that happening has been scalability. Like you can actually see on Bitcoin, once it hit the limit, all that usage just overflowed into other chains. And I think you can see the same in Ethereum. It also hit a kind of limit. Again, like transactions were like $50 or higher, and all of that usage then flowed into other chains. And so obviously usage is growing over time, but this constant splitting off into more chains, splitting off into other cryptocurrencies or more layers and stuff like this is the main thing that's kind of slowed everything down.
Absolutely. And by the way, all of those people are the idiots who did not look ahead, right? Like there was tons of people, having lived through that era, who basically just did the basic math and didn't even bother to start an idea up, because they said, well, I'm going to consume 25% of the Bitcoin block space with just my, idea in hopefully its first year, right? But in order to make this successful, I need to consume, 10 times the Bitcoin block space, right? So why even start?
Right. I mean, I remember when there was the initial, I wouldn't say it was an announcement, it was kind of like news, but it was official news that PayPal were investigating using Bitcoin for payments in like, I don't know, it's probably like 2014 or something like that now. But it was for payments. And then they obviously the block size kind of basically got hit, capacity was
Mm-hmm.
reached, and then they gave up on that because obviously
Of
it
course.
couldn't be used as PayPal payments. Like they handle like tens of thousands, at least hundreds. No, I think it's like 300 or something transactions per second. So, many times more than Bitcoin can handle in total. And now obviously you can use Bitcoin on PayPal, but it's just as an investment. It's not for paying for anything. Like it's not like it comes up as an option for payments, when you go to pay a website via PayPal.
So actually, there is a slight goodness there, which is you can actually now sell your cryptocurrency on PayPal, and then it becomes presumably your native currency. For me, it becomes dollars, right? And then you can use those dollars to pay for things. So it's a two-step process, but at least they've gotten like just a tiny bit closer, right?
Right, but the point of them having Bitcoin or cryptocurrencies on PayPal is purely for investment purposes and not
Yes.
payment purposes.
Right. You certainly can't pay every day with these cryptocurrencies, right? Because the blockchain doesn't have the capacity. So what they want you to do is move the cryptocurrencies over, sell a big chunk, right? And then pay in US dollars, for your coffee or whatever you're paying with PayPal. Yeah,
Hmm.
so it's a problem, and people just never even bother to start stuff up because of capacity issues. So what we need to do is have that capacity, even though we don't use it. And I'm not a big fan of like, creating fake data on the main chain just to prove capacity. But surely we'll have test nets that are running at high capacity eventually. Once like Nexa coming from Bitcoin Unlimited's BCH work, its capacity is vast compared to what it's doing now. And I don't think we need to prove anything. But eventually, we'll be running test nets that just are constantly creating a massive amount of you know, fake traffic just to show that it's possible, right?
I definitely think it would be useful to kind of prove to people that on testnet that there's a certain level of capacity already there, and then obviously as we make improvements in how like validation happens in hardware, just do another test and go, look, this is actually working at this level now. One,
Yeah,
just for
but like on a
marketing
test net,
purposes, but
I
yeah,
don't want to do a test. I just want to have it constantly running, right? So I agree with you. It just needs to be in the list of things to do. I would like to get the wallet out first and stuff like that.
sure, like definitely capacity is not like a problem for us right
Right.
now. Although we
Exactly.
did get obviously those large number of transactions be made because of the consolidation that
Hmm.
X by Tron were doing. But yeah, so we've got a couple more questions. I don't know if you've
Hmm.
still got time for those because obviously we've been chatting for a
Yeah.
while.
Yeah, I can go through them, but let's
Okay.
yeah, we'll go a little quicker.
Okay, there's only two more to go. So
Hmm.
the next one is, what do you believe will be the biggest hurdle our community will struggle with? I mean, so that is, depending on how you look at that question, it could just be the same question as before, but let's take it from more like a social perspective, because I think that also has a big impact in
I think it's just
cryptocurrency.
the inertia that we were just talking about, right? Like there's so
Hmm.
many opportunities, but asking like the whole world to change the way they do things, even if it's a little bit easier, is a hard thing to do. So we need to find areas where, Nexa gives you just, really is compelling. And then we need to explore those. And then from there, we can move on to things like your monthly rent payment, which it happens once a month, right? You don't really need, you can do it with a personal check, right? It can be awkward. So I think that's what the biggest hurdle is, right?
Yeah, making it useful for like the average person.
Hmm. Exactly.
Hmm. Okay, last question. So, how would the Nexa blockchain be protected before quantum computing becomes a risk?
Yeah, so we're definitely tracking, the quantum advances closely. Our president is very interested in what's going on there and is watching it. So, to give an example, there is actually an MR in the Nexa full node open right now that is the first step in moving the Falcon, signature scheme into Nexa. Now we don't, it doesn't actually, it just moves the code and builds it right now, this first initial MR, right? But for sure, we plan to track quantum computing and move our crypto systems forward as they happen, right? So, that may mean that the hierarchical deterministic wallet as it's currently formulated won't work anymore, but we would still be able to create like a deterministic wallet um, with a limited form of hierarchy. Basically, what you're not going to be able to do is hand out a public key that can generate other public keys, right? Without knowing the private key, basically, because that is using, the some features of elliptic curve mathematics that won't exist, as far as I know, in other crypto systems like Falcon. So, but this is relatively small. So, I think that um, this is going to be a little bit like Y2K. So long as your blockchain is aware of it and makes moves, then you're going to be okay. And recall too that your ECDSA public-private key, I'm sorry, your Schnorr public-private key is hidden behind a hash, right, on the blockchain, and the public key is only revealed during spend, right? If you use the pay to script, like if you use the pay to template formats. So even if someone has a quantum computer that can break public-private keys, the idea that it could do so within the average block time of 2 minutes is probably extremely unlikely, at least in the beginning, right? So, there should be plenty of time to move your wallets over to, there's plenty of time for us to deploy, first of all, a quantum resistant signature scheme, and then finally for you to move over before, there's any chance that a quantum computer could attack your accounts.
I'll just quickly explain some of the ideas there, just in case people don't understand.
Yeah, sorry,
like,
I kind of
how
assumed that
works.
people understood what's going on with quantum computing. Go on.
Yeah. So the problem that occurs with quantum computing is that at a certain level of capability, it's possible to derive the private key from the public key. That's correct, right?
Yes, but
So
that cryptographic hashes remain much more resistant to quantum techniques.
right. So because the private key is hidden behind a hash, the only time that this attack can happen is once you've published the private key to the blockchain in your transaction. Public key to the blockchain in your transaction. So you've got like this maximum 2-minute window that this quantum computer has to generate the private key. But the goal is to have a new signature scheme available that is much more quantum resistant, that you can just send your money, essentially your Nexa, over to the address that uses the new signature scheme, so that even if they have this incredible quantum computer, your money will still be safe. You just transfer it to a new address and then it's fine.
That's right. And they would have 2 minutes, even if quantum computing is like a done deal and out, which is not yet, right? But even if you forget about your address and it's 30 years from now and someone's done that, a person would have on average 2 minutes, right, to crack your private key from the public key that was revealed as you move it to the new address format, right? So this seems highly unlikely, and even in a case where that happens, I hate to say this, but we could even run a trusted service, right? Like a trusted miner. So you would only give that transaction to this sort of known trusted miner, right? And so then they would, commit it to the blockchain without revealing it to the rest of the network, right? So that these are all possibilities. And I just want to say one final thing is, we are not inventing cryptographic quantum resistant cryptography, right? We're going to be using cryptography that's basically being standardized, and sort of the world's greatest cryptographers are agreeing is quantum resistant, right? So this is
used by the military and stuff like that.
Yeah, I mean, it's like there are quantum algorithms and encryption schemes that are being evaluated by organizations who are devoted to this sort of thing. So we're not like in Nexa trying to invent new crypto schemes ourselves, and we even are going to be using their reference code. So just want to make it clear that because we don't have like PhDs in cryptanalysis, as part of Nexa, but we don't need to, because we can rely on, these publicly agreed, crypto systems.
Right. Satoshi didn't invent cryptography.
Exactly. And so we're trying to be more, as we said, our philosophy is to really focus on, applying blockchain technology, not so much, inventing new crypto systems and so forth.
Yeah, that makes sense.
Yeah.
Excellent. So we go through all the questions.
Great.
I'm sure there's like 1,000 other questions that are going to be wanted to be answered like down the road, but we've got plenty more time for that in the future. So yeah, there's a really good conversation. We covered a huge amount of ground there. I really hope that has helped people understand kind of what we're doing with Nexa. what the plans are for the future, and like all the technology and effort that's already gone into it and what's going to be going into it. It's just a ton of work. Yeah, so I really appreciate you taking the time to chat with me, Andrew.
Great.
Looking forward
Thank
to
you for asking the questions and having a conversation about this.
Yeah, I mean, it's thing I'm most fascinated by. So
Yeah.
always happy to chat about this stuff.
Okay, great.
Excellent. So we'll wrap up there. If anyone else has any more questions for the future, we've got the AMA channel, so you can stick them in there, and we'll kind of collect them up for future discussions to be asked. Yeah, and thank you all for listening along. Yeah, we'll speak to you all soon.
Thanks.